Hello, welcome again. I'm Marek Marczykowski-Górecki, and I will present a host and guest suspend under Zen. A bit about me. I'm CTO of Invisible Things Lab and project leader of Qubes OS. And how does host suspend works if you run Zen? So what you'd like to do is to just, in case of Qubes OS, is to click suspend in your desktop environment, or maybe just close your laptop, and things should just work as it would be native OS. So in case of just Zen without any added parts, hardware domain usually dom0 suspends all the devices, like when you do systemctl suspend or write mem to sys power sleep, whatever. The dom0 kernel suspends all the devices. However, the drivers do that. Then tells Zen to suspend the host, and then pauses all the guests. Then execute appropriate ACBI method to suspend the guest, and to suspend the host, and the host is suspended. Then we wait for some wake-up event. Then get started again, and hopefully resume all the state correctly. And then unpauses all the guests, which includes dom0, and dom0 resumes all the devices. If you have just PV guest or just PVH guest, everything is fine. Mostly. But there so this is mostly transparent for guests. dom0 event is aware of the suspend, but all the other guests are not. So they, for example, see some time jump because it was paused, not running for some extended period of time. And some kernels are not happy about such time jumps. Some software, user space software, is not happy. There is a workaround by forcing clock source Zen, which gets updated after the resume. It's very much not perfect. We used to do that on Qubes for a long time, and it was good enough. But then we noticed why guests are running such slow, because if you use clock source Zen, then every time guest user space application in a guest tries to get a time, it is a syscall to kernel. So it's not perfect, and also it's very much incompatible with PCI passthrough. If you just pause a guest that has PCI device and try to suspend host, very funny things may happen. This includes host not suspending at all, or just freezing somewhere in the middle because devices are not properly suspended, or if you are lucky, that those devices not working after resume. Sometimes unloading and loading the drivers is enough to fix it, sometimes it isn't. So it's very much not perfect. And here I still talk only about S3. I will get to S0ix in a moment. Okay, so what to do about PCI devices? Generally, drivers needs to be aware about the suspend. So if you do PCI pass-through, you need to tell the drivers in that guest, in that domu, to prepare for suspend. We do that on Qubes by simply suspending guests that have PCI devices. There is guest suspend in Zen. It is supported already for a long time. It's used for saving guests and restoring, and also for live migration. So we use that to suspend the guest, but not actually dump its memory to disk, but for migration stream, but keep it in memory. This work is in Zen upstream for a long time. There is libxl suspend only. I had it somewhere on maybe a later slide. And that simply shortcut the suspend function to not save the memory, but stop after the guest get told to suspend and confirm it got actually suspended. Yeah, so in most cases it works. In some cases it still needs to unload drivers. For a long time we didn't know why, but when worked on S0ix SAS work, it becomes a bit clearer. Because apparently there are two code paths in Linux kernel for suspend. One is called freeze, and another is suspend. And apparently the stuff used to save a guest to disks is using the freeze path, which do not, depending on the drivers, not all the drivers have the callback to suspend devices when calling this freeze path, only for suspend. Yeah, so that was a problem later. So for a long time we had that workaround to unload the drivers in a guest before going to suspend the host and load them back after resume. Yeah, it worked most of the time. Yeah, so right. For live migration, the freeze works. For safe restore, probably works. I'm not sure what happened if you use PCI passthrough. We don't use safe restore on Qubes, so I don't know. And for suspend, the suspend method is needed. What we currently do, we have a kernel patch in DOMU that simply switches the method. It's very much not upstream ready. We need to analyze why and where actually which mode is needed. Because I had a suspicion that the suspend may be needed for safe restore too. I'm not sure about the migration because you don't do PCI pass-through with live migration, I think. Yes, we do. Oh. Okay. So. Okay, so yeah, so there is some. This needs some deeper analysis, which one actually is needed. There was also some issue with PV devices and suspend.
To be very blunt, I think you fixed an open bug we've had for 2 years. just this.
Yeah, so there is a patch for that. It is I think it is posted to Zen. I'm not sure if it's posted to Zendevil, but there's definitely a link to it posted to Zendevil. Yeah. Okay, so everything was fine. We had host suspend working on Qubes OS for a very long time, I think since Qubes 1.0. Yeah. And then S0ix happened. So this is something that is needed in practice to suspend modern CPU because ACPI S3 is going away, thanks to Microsoft. So how is it different? First of all, the main difference is that its CPU decides where to go to sleep. It's no longer some ACPI method or any other triggered from the OS to tell, okay, now go to sleep. It's, you need to meet a bunch of conditions that CPU decides, okay, I have nothing to work, so I will go to sleep. Yep.
Clarification about the entity that decides when to sleep.
C state is just one of
This one. Yes.
All the IP blocks in the PCH and stuff is like most of the requirements. The CPU C10 is, I guess, only one of all of those.
Yeah. Yeah. So generally, you need to suspend everything and hope the platform will actually suspend. Nice thing is that if you fail to suspend something, you are not ending in a broken state. But the bad part about it is if you fail to suspend everything and put your laptop in a backpack, you end with very hot laptop, which is not great. Yeah. So there is some help to debug issues here. There is a table of all the requirements for different states. There is yet another column that didn't fit on the slide, but it is if you actually manage to meet this requirement. And this is not the whole table. This is like 1/5 of it or something. It's very long. Yeah. So we tried that on Qubes, and we found some issues. So first of all, legacy mode. This is something that is incompatible with S0ix. So we have, but this is necessary to, I think, calibrate the clock on the Zen startup or something like that.
No, it's code we inherited from Linux that we haven't actually deleted yet. We need to delete it.
Yeah, but the
So that the IOA bit resides in the route.
Yeah, so it was supposed to be a check that the IOA bit had been configured correctly, and it was relevant back in 32-bit platforms. It's not really relevant in 64-bit platforms, which is why my preferred way of dealing with it is just deleting it. Of course, I've got to not break the rest of the system that's doing it. So.
Isn't Zen like a fork of Linux 2.2 or something?
Yes.
Okay, but the point is, it is needed only when booting Zen and can be disabled later. So, yeah, there is a patch. I'm pretty sure it is committed already.
Yes, yeah, we did take that patch.
Yeah.
I think.
Yeah, so there, the other thing is Tiger Lake support in M8 idle driver. There was some discussion, I don't remember exactly the just a disclaimer. All of this work I'm mostly reporting what Simon Kaiser from our team did. He is way more understanding on internals here, but he couldn't be here. So, yeah, so there was a support for Tiger Lake in M8 idle driver needed to have it done, have it working on Tiger Lake. And we basically compared what's happening in Linux similar driver and port there are a bunch of hard-coded values. Then for debugging, we need to give access to some MSRs to get the residency counters to be able to debug this. It's not strictly necessary to suspend to happen, but it's very helpful to like debug and work on this. This is something we currently carry in our patch queue. There was some disagreement to include this patch upstream. I don't remember details. I will have links to mailing list later.
It's to do with DOM0 not necessarily seeing the full system.
Yes, I think there was some issue with number of CPUs or something, like if DOM0 doesn't have all the vCPUs or something like that, or mapping to vCPUs and physical CPUs.
It's the scope problem. For laptops, it works fine. For servers, or actually for workstations now, which have multi-die, where your MSR scope is one die, not the full package. That goes wrong because DOM0 doesn't know which
Yeah, and another thing we discovered is on-demand CPU frag drivers was causing a lot of wake-ups. It keeps some timer and it's wake up constantly. So we got like 50% of sleep or 40% of in residency.
That sounds like we should disable that governor then, generally. I think it's still the default.
It is the default one, and yeah, but we just can switch to another one for the suspend time, and it works.
Can you say that you disable all timers before going into suspend?
So that's mostly for the driver, so you don't have interrupts happening. So it's mostly up to DOM0 to, yeah.
If you go back to the table, yes.
Yeah.
So everything there that has PLL in it, so USB PLL, OC PLL, those are the phase lock loops, which are the ways of generating timers and clock signals, and they take quite a lot of power.
No,
So
but I mean, if you disable all timers, then the timer for the on-demand frequency governor should also be disabled? And should
No.
all hardware time sources. Because what you have to do is you've got to turn off hardware time source. If and only if you've said, well, I want no more interrupts from this. The on-demand governor just has a Zen timer saying, I'd like
Yeah, but that
7
timer
Oh.
shouldn't be configured anywhere because
There-
the hardware is disabled.
There is a catch with all this suspend I have on the next slide. Okay, so we do that. And there are also some changes in Linux. There is wake-up support for Zen PureQ. Without that, you couldn't wake up the system. There was some flag missing. I think this patch was committed in Linux finally. I'm not sure, but yeah. There is also some Qubes-specific issue that we compiled the kernel with PCI hot plug disabled, basically because we don't know yet how to handle a hot plug safely, so we don't want random PCI devices to appear and be connected to DOM0 if you plug some, I don't know, Thunderbolt, whatever. This needs to be properly fixed at some point, but currently we have hot plug disabled, but this also means that the Thunderbolt driver in DOM0 is not happy and it's like not doing anything, including not suspending the Thunderbolt bridge. So it's we have some hack for that. It's ugly, but it works. And then you write, you need to ensure that DOM0 has S2 idle and mem sleep. There were also some changes in QEMU. So first of all, power management related to config space was trapped and emulated in QEMU. So with PCI passthrough is, well, then guests couldn't suspend the devices properly. So you may want to look at this patch. It's not upstream yet. So we connected it to power management PCI dev option in toolstack. I'm not sure. We wanted to have it in Qubes 4.2 and have it opt-in. So any change in behavior should be limited if you opt into S0ix. That's why it's hidden behind an option. But maybe it should be always enabled. I'm not sure. Okay, so how the suspend process looks like. We suspend all the guests. So here's the libxl function name. This time we suspend all the guests, not only those with PCI devices, which has a nice side effect. We don't need the clock source Zen anymore because Linux kernel knows that suspend happened and need to resync the clock after resume. Nice. Switch away from on-demand CPU governor, suspend DOM0 S2 idle, and Zen doesn't know anything about suspend. It just says that, okay, no domain, all the domains are idle. There's nothing to schedule. Okay, so it's fine. CPU is happy. All the devices are suspended. it's going to sleep for most of the time. But funny thing, if you have serial console, you can still interact with Zen. You can get messages or using debug keys. Yeah.
The CPU still works, right?
Yeah, CPU still works. Yeah. So that's, there are probably some part in Zen that needs to be adjusted to like even more sleep, because the end result is we get about 90% of S0 i3 residency. It's not as good as native Linux. There is, yeah, we didn't. We tried to find what actually is the problem, but we didn't complete this, and it needs some. We have some suspicion it is about scheduler, but I don't know. Yeah, we did test mostly on Intel. We have some reports that it's not enough to suspend AMD. But looking at at Linux, some parts of the work on Intel are most likely relevant for AMD too. One thing to enable debugging this, we need similar MSR access for DOM0 to actually be able to debug it, because currently DOM0 doesn't report those requirements if you run AMD. Yeah, and there is, it is available in Qubes 4.2 as opt-in, and some patches are upstream, some are posted, some are ugly enough we are not happy to post them. So what's left to be done? Figure out this freeze versus suspend code path. This is not the, I think it's the easiest part. But not the very easy one. Thunderbolt, yeah, we need either some nicer solution for Thunderbolt driver to suspend a device, even if PCI hot plug is compiled out. I'm not sure if Linux maintainers will be happy to talk about it.
Different solution there.
And alternative is
Of course.
I was going to introduce you to Teddy, who is currently making IOMMU that para-virtualized inside DOM0.
okay.
At which point you'll have, your DOM0 will be able to have a proper IOMMU quarantine context to put all the hot plug devices into. I think is what Linux does at the moment anyway.
I would be very happy if that happens.
Can you make
Let's talk later over lunch.
Yes, so that's thing. Proper PCI pass-through, PCI hot plug we'd like anyway at some point because they're Thunderbolt devices. Yeah, and upstream remaining patches and work on the remaining 10%. Yeah, so here are links. There is a post on Zendevel with all the links to all the patches and basically summary of this presentation. And there is also Qubes issue with similar links and also to all the patches, and also test results on different machines. We have 5 or 6 different machines tested with Intel with mostly positive results. Not only positive results, but yeah. Okay, any questions? Yes?
One remark and one question. Firstly, about the CPU fracture.
Mm-hmm.
Yeah, I have recently stumbled upon an issue with Intel hardware P-state driver, which is used for CPU frac. And on certain machines, it may occur to be over-aggressive in terms of power saving. So I had an issue where I couldn't achieve full bandwidth on the Ethernet interface unless I had externally stressed this for the CPU. On the other hand, it's probably possible to not be optimized enough to actually not wake up the CPU regularly. So maybe changing that driver to something else by disabling hardware P-state may be a way to improve the efficiency efficiency on the S0ix.
Maybe.
If I disable the hardware preset in the BIOS, I got rid of the problem of the need of stressing the CPU, and I could achieve the full bandwidth, for example.
Yeah.
The driver changed to the ACPI CPU, right?
Yeah, so for hardware p-states, we have it enabled by default in Qubes if it's available, and we got reports that without that, it's the power usage of Qubes system, so it's not just Linux and it's several Linuxes. It's much worse than compared to native Linux, which is not the case on the older platforms when there is obviously some overhead, but we've got reports of factor of 5 or something like that. It's ridiculous. So that's why we enable hardware p-states by default.
So that was
Yeah.
the remark, and now the question. How does GUESS or Zen deal with opportunistic S0ix? For example, the system typically can place some PCI devices in D3 codes, which is almost equivalent to dropping off the PCI device from the bus. So how does system react to such cases?
We haven't enabled that. I think in Linux you need to explicitly opt in to that. We didn't try it, but I don't.
I can tell you it will explode in various weird and wonderful ways.
Is that because Windows doesn't do it and it gets no testing?
No, it's because a whole bunch. There's a lot of code in Zen that attempts to figure out when that has happened, except it is a perpetual top-two race between Zen and what DOM0 is doing. And so long as they kind of cooperate on it, it's not too bad. But we've had a lot of problems where we have, for example, got unexpected resets on a card, and there's basically nothing you can do if an entity isn't aware of the reset. So I spoke to Simon about this. I think the best, because all of that stuff is AML, and we provide the AML into the guest. I think what we might want to do is provide AML that is a merge of the system AML and a notification going to the hardware domain to say, by the way, I'm shutting this down, at which point it can propagate the notification to wherever it needs to go. Or maybe we trap and emulate the register. So D3 holds a register in config space, isn't it? So
I-
No, if the device is D3 code, you have completely shut it down from even cut
Yeah.
off the power.
yes, but putting it into D3 cold is still a write into its.
But then how could you get it back out?
The sequence is that you put it first in the D3 code, and then issue this magic sequences through ACP methods that actually put it into D3 code.
Okay, fine.
Yeah,
It's an
then
active
it
method,
has-
we can still hook it.
Yeah, yes, you can hook it, and you can actually probe for the state of the device by reading the GPIO responsible for asserting the reset and the power pins.
Oh, yeah.
Okay.
Well, I think the answer there is if we're going to do this nicely, we're going to have to provide some AML that is a merge of the system AML and the requisite notifiers, so the rest of the system can at least be aware that this is happening.
Okay.
In our case, actually, we probably not only need to support these recording, just mentioned, we probably need to power down the whole the PCI device. We probably need to support the PCI hot block based on the DOM0, how to handle this kind of case. And once power, for example, if there is a discrete GPU in PCI slot, we probably need to support the PCI hot block.
Yes. So.
The Zen guest. Maybe this GPU is a pass-through in one guest VM from you.
Yeah, so PCI pass-through is needed for various areas, not just the suspend. So yeah. Okay.
Could we?
I guess it's lunchtime or something. Yeah.
Right now,